Okay, next up we want to be integrating cosecant squared x. Okay, and so this is actually a standard integral. I know that the answer should be negative cotangent x plus c. It's just the standard answer. It should be integrals that you're actually quite quick with. But assuming that we don't know that, it would be tempting to choose to try and use substitution and write out the fact that this is equal to the integral of 1 over sine squared x dx. And then next up, we would want to say that u is equal to sine squared x, and then find the derivative and continue like that. But what you'll get is that the derivative of sine squared x is going to give you another term with an x term. And so when you say dx is equal to du over what's left, it's going to give you a function of x. And so when you try and insert it here, you'll be left with u terms and an extra x term, and we can't integrate that. And so this is not the correct method to continue down. Instead, I'm going to make a slightly informed substitution and instead choose u is equal to cotangent x. And so that would be cos x over sine x. That means that du would be equal to negative sine x du over dx is equal to negative sine x into sine x minus cos x into cos x all over sine squared x. And this becomes negative sine squared x plus cos squared x all over sine squared x. And so we get negative 1, because this is equal to 1 according to the identity that we know, over sine squared x. And this would be negative cosecant squared x is equal to du over dx. And that means that du is equal to negative cosecant squared x dx. And so we can just write that. And you'll notice that the reason why I made this substitution was intentional. So let's just write out negative cosecant squared x dx. So that means that dx is equal to du over negative cosecant squared x. Yep, and so clearly here we can see that we are getting it into a form of f prime x du over f prime x. And so these two will cancel. And so now if we use the substitution that we have here, we have the integral of cosecant squared x du over negative cosecant squared x. And so because u wasn't appearing anywhere here, I just proceeded by substituting in our dx. And so these two will obviously cancel, and we get negative the integral of du. This will give you negative u, and then just put back in what u actually is. So this becomes negative cotangent x, and then because the integral is unbounded, that becomes negative cotangent x plus c. This is why it's just known as a standard integral, because we made a basically informed guess.